Beginning with problem number 6, I'm going to look a few problems out of chapter 10 for you. The first thing I did was I entered these values into my TI-84 calculator. I had to push stat, scroll to edit, and then I entered these values in list 1, 2, 3, 4, and 5. So in list 1 I had 13, 16, 7, 15. So I just went down my list. So my table actually looks a little different, but I entered them as list 1, 2, 3, 4, 5. Then I did stats, went to test, then went to ANOVA. Now the reason I did number 6 first is because your calculator does ANOVA analysis, but it only does ANOVA analysis with data points. I'm not sure why that they don't have it programmed in the calculator to do it when given the statistics, but they don't. So we'll have to do those actually by hand. I guess it really is the chi-square distribution and this ANOVA analysis are the two drawbacks with the TI-84 calculator, but you can use a math software package and it will do these things for you, but it does cost a few $100s. So that was why I elected to use just a TI-84, plus most everybody has one. Okay, carrying on with this, we do our ANOVA analysis, and you will get a test statistic of 3.2088. You will also need the rejection region so you can decide whether or not you're going to keep it or reject it. And in doing this, our alpha was 0.05. There he is. So I'm going to look at my table, and I copied the table off here for you so that you can look to see where I'm getting these numbers. The I, my I was, let me write down my I happened to be 5, and my J happens to be 4, because this would be how many different lists I have straight up and down, and my J is how many entries in that. So my I minus 1 would be a 4, and then my error, or I times j minus 1, would then end up being, for our results, 15. So I go over to my tables, and I go 4, 15, I want the 0.05 level, and there she sits right there. So when I compare these two values, I look at this and see that my test statistic is indeed greater than my critical value, so I would reject my H0. It might be worth noting that the p-value that you get for this p-value from your calculator on your ANOVA analysis, which is my favorite way to do this analysis, the p-value is 0.0432, and this p-value is less than my alpha, which is 0.05, so I would also reject according to the p-value technique as well. For the next part of this problem, we're supposed to use the two-piece procedure. So I'm looking at this Q value, my Q, and then I need my alpha, which I got from the other side, which is 0.05. My I, which I wrote down over here, remembering it is a 5. And then this error, which would be 5 times j minus 1, so 5 times 3, which is 15. So using this particular technique with a 5, and then going down my column to the 15, I need the 0.05 level, so I'm looking at Q being 4.37. So I'm going to do a width calculation, which is what we're doing now. So this is the formula that you will use on all these problems for the width. This is 4.37. There's a square root of, you should get your MSE from your ANOVA analysis. So when you did your ANOVA, it goes ahead and gives you the MSE. And the MSE I got was 16.667. And I'm to divide that by the J value, which was 4. Crunching those numbers, then you get this width over here. So, there he is, whoops, over there. Okay, so the next thing I need to do, because that's the width, next thing I need to do is go and get the mean of each of these lists. And what you can do to get that, just a quick way to do it since we already have them in the list, just go and do a one variable statistic on each of these lists. I mean, you could add them up and divide it by however many, but you don't have to. You could just hit stat and then calc and then do a one variable statistic on all of these different lists to get your mean. I did that, and what I got for each of these is, here's my mean on each of those. I just wrote them all in when doing my one variable statistics. And now I need to see what the difference in all of these values are. So if I take the difference between these two, I would get roughly, what, 5 1/4? And that is within the prescribed width. So 1 and 2 are within tolerance of each other, you can say. These two are definitely, because they only have a difference of 0.5, so they're definitely within 8.79. So you just go down through and check each of these, 1 to 2, 1 to 3, 1 to 4, 1 to 5, and see what the difference is. If the difference is over 8.79, then you would say there's a difference and you'd check that box. On each of these, they were all very close, and so with my two keys method, what you would say is that there are no significant differences, which is different than what the ANOVA F test would give me. So it's interesting to note that these two different methods, which are both valid, are in conflict with each other. So both, they are, depending on which method you use, they are different and they're also not different. Statistics is fun this way. It just depends on what method you use. Normally they are in concurrence, but it's nice to see that they don't always agree, the two different methods, or even however many methods that you happen to try. I gave you the formulas here. Basically, you're just going to crunch these numbers. Here are my formulas that you would use. If you're given the data, your calculator calculates all these numbers for you, so you don't have to. Seeing as we needed them for number 2, I thought I'd show you how to do number 2 with the formulas, but once you know the formulas, it's just a matter of punching the buttons. So I'll go in and put the numbers in for you. Okay, I plugged in all the numbers and crunched them for you. This is what I get for this particular problem. Of course, they go ahead and let me know that my I is, it's in the problem, I is 3 and J is 9. Just to note that. And here when I did this 24, I said that I was 3 and the J was 9, so 3 times 8 is 24. That's where I got that. And then my F value, which is what goes right down in here. Now we have to kind of look at this p-value a little bit awkwardly, really. I went to table A9, and I'm going to go backwards in figuring out what this particular p-value would be. I know that my V1, so we said that our I was 3, so this would be 3 minus 1, which is 2, and for this one, I'm going to say that the I was 3, the J was 9, so 3 times 8 is 24, because it is J minus 1. So that was why I copied off this part of the chart here. So I'm in this column here is where I'm looking. And my test statistic, what my F value was, my F value was 1.489. So it's way up here, 1.489. It's not even within any of these. If it was within one of those, I'd say it was in between, let's say it was 2.6. If it was 2.6, I'd say it was in between 0.1 and 0.05. So I would come over here and pick that one right there. But ours is way off the chart, so my p-value is greater than 0.1 because it's not even on this chart. And that's it. The rest of the problems are just variations of these two.